Huh? Dude, I don't understand that, man. I don't want to.
Find all t from which the tangent line is horizontal.
So just the
Derivative tells you tangent line. What about horizontal part? Slope is 0. So where slope of the tangent line is 0. All right, so here comes our function. Pull it out to me, please. All right, so take the derivative of that. You're going to take the derivative and set it equal to 0. So you're going to have to know how to factor some sort of third-degree polynomial. Let's see what the derivative looks like. Homework papers out, so I don't get to get them back this time. Maybe. So long, you know, the story. I don't have any of yours. Here's that.
I don't think so.
Okay, so the derivative will look like 4t cubed plus 12t squared minus 16t. So that's not going to be so horrible to factor because it's got a common factor. In fact, it's got a common factor of 4n of t. So let's pull out a 4t all the way through there. So yeah, 4t. And that'll leave me with a t squared right there, plus 3t here, minus 4 right there. Set that equals 0. Any factors of 4 opposite in sign that add to 3? Plus 4 minus 1. So we've got that factor. That wasn't as bad as I afraid it would be. So now you set each factor equal to 0, and that'll give you 3 values of t. 4t is equal to 0 when t is 0. T plus 4 is 0 when t is equal to negative 4. And t minus 1 is 0 when t is equal to 1. So I wanted to do a similar problem, but with funkier exponents.
Oh, no.
Find it. Next minute. Here's your problem. Do the same. Four to 1 over the square root of t times t plus 9. The derivative of this thing is going to be 0. Derivative isn't the challenge. Simplifying the derivative so that it has positive exponents in factor form, that might be the challenge. Right? Not you. Do it. It's like my house, I got too many remotes. That's that one. Don't do it. No, don't do it. Stuck with that, I just gotta write bigger. Getting anywhere? We got a value of t yet? Where the first derivative is 0. Find out. All right, so I'm going to write it as t to the negative 1/2 times t plus 9. I'm going to go ahead and do the product rule. It's the first times the derivative of the second. Are you okay with 1 being the derivative of the second? And then the other way, times the derivative of the first. So negative 1/2, what's the new power going to be on t?
3/2.
All right, okay? And now we are going to go ahead and multiply it out from here, I guess. So I get a t to the 1/2. When I multiply like bases, I add exponents. So when I multiply here, I'm going to get the negative 1/2 t
Is that negative?
to the negative 1/2.
It's the first one's just gonna be
Sorry?
the left t.
Say it again?
The first t, that's what's gonna be.
Yes. And then here, I'm going to get a minus 9/2 t to the negative 3/2. These are like terms, so I can add them, adding the numbers in the front. So I'm going to get a 1/2 t to the negative 1/2. And then I've got this one here. I'm going to write them with positive exponents. I'm going to add them and put the t's in the bottom and make their exponents positive. So when I add these two, I get 1/2. And then I'm going to get a t to the positive 1/2 down here. Then I have minus 9/2 with t to the 3/2 down here. Okay there? I think next I'm going to get a common denominator. Between the 9, I've already got the 2's, but now I'm going to need a common denominator of t to the 3/2. So what do I multiply t to the 1/2 by to get a t to the 3/2?
T over t.
Just t over t. Let's multiply this first fraction by t over t. And then we're going to have the common denominator. When I multiply that by t, I can just put it over here in red. So both have a 2t to the 3/2. My numerator will look like t minus 9. Then I have 2t to the 3/2 on the bottom. Okay with that? Now notice that my denominator is 0 when t is equal to 0. So the derivative does not exist when t is 0. Do you know why?
What is the, whatever non-dual is called, isn't it?
Yeah, my original function doesn't exist for t is 0. Right? The domain of this function is strictly positive numbers for t. So we would have anticipated there's no derivative at 0. Now the derivative is going to be 0 when the numerator is 0. I'm getting t is equal to 9. Anybody else get t is 9 when we did this?
I didn't have the basis.
Did you just separate them and cross multiply maybe? You have done that here. Just put a 0 over here and just separate your fractions and cross multiply. You have to be careful with that a lot of times because you don't want to lose a critical number or the 0. So I just got the common denominator to do some practice of doing it.
How would you do it the other way? Because sometimes you won't be able to do it.
If you just went back to this step and just put the 0 over here, and you have the 1 over 2t to the 1/2 minus 9 over 2t to the 3/2. Bring that one to the other side. And now just cross multiply. So I have 18 t to the 1/2 is 2 t to the 3/2. Eventually, you're going to have to factor. Eventually, you'll get down to something like that.
Just divide that. You don't have to.
Well, you gotta make sure the t is not 0.
Yeah.
Then you divide by that. Then you've gotta look up here that make sure you're not throwing away a 0.
Yeah.
So if t is not 0, then you can divide by t to the 1/2. You can also divide by 2.
That's it.
And that gives you 9 is equal to
Just two.
just t. But you have to pay attention, because what if 0 was in the domain? Then you gotta keep it.
Yeah.
Is there other more question on the question? I'm gonna ask you something like this on your test. If you can simplify your derivative enough to tell me where the thing is 0. I've got one on the review sheet. If you have to practice those. I think the review sheet has the answers.
Okay, I haven't.
Yeah, I think they're in there somewhere. Yeah, I put the answers on there. Some of them are even right.
Wow.
No.
That'd be fun.
Just to get you nervous if you're doing something wrong. Okay, so here's another web word problem. You have some sort of function h described as the product of a function with itself. We want to find h prime at 1 given value of f at 1 and value of f prime at 1. Let's see those numbers. 17? 17 homework problems?
Yep.
What a whip.
That's what I said when I saw it.
Figured you did. Let's try making an even number. 17.
Should have made it 18.
Should have made it 18.
No. It can't be up.
So what this problem is trying to get you to do is do the product rule. If you don't know the function itself, the only way to find h prime is symbolically using the product rule. And so it looked like this. H prime in terms of x is going to be our first function. What is this bad? Times the derivative of the second. Well, the second one is the same as the first. And then plus the second times the derivative of the first.
That's a rule. I appreciate it.
That's the product rule right there. Just that this particular function has matching factors. So you get two of the same factor.
Can you block it too?
I don't know where I put it, so I'm gonna keep it. And now I'm going to evaluate this when x is 1. So this says that h prime at 1 will be 2 times f of 1 f prime of 1. And now we have those numbers given to us. F of 1 in this example was 7, f prime of 1 was -2. What else you want to do? Yes, sir.
Was going over the technical questions,
Okay.
and there was like, a couple questions on like guessing limits.
Guessing limits.
Yes, and it was like, I forget the exact function, but it just gave you a function of like n over like n plus 4 or something like that. But it doesn't give you like a graph or anything. Are you supposed to just like memorize that graph or something like, or?
Back in the section where we were guessing
It was like
limits.
1.1.
Um,
I'm kind of confused about how to find the limit as like n goes to infinity. And then when you put more of the three graphs in.
so you would need the graph, is what you're saying?
I don't know, like, would you need the graph? Or
Well, I don't know. It depends on the function. Sometimes I can kind of take my
Or
way.
it was like 2n over n plus 4.
N over n plus 4.
Maybe with the base graph of that looks like, but I don't really know. How old it is.
Were you interested in what happens near -4 or?
No, you just need, x goes to infinity.
N?
Yeah.
I didn't know we did infinite limits yet.
Yeah, it was in section 1.1. I mean, I just graphed it on a calculator and I figured it out.
I don't see anything with infinite limits.
Go to, it's like section 1.1.
I think if you know the base, you
Yeah,
can just
just
do a really big number to see which way it's going.
I don't see one. I'm at 1.1. I don't want you to do infinite limits just yet unless they're logs and exponential functions, because you know those graphs. So what? Yeah, we'll do some more of those later on in chapter 4, I think. We won't worry about infinite limits just yet. Yeah, but I still don't see any infinite limits. Here. I'm looking all over. Nothing. None of the limits in this section should be infinite just yet. Like this problem, if you know how to do this limit. I want the limit as x goes to e squared. I've got the natural log of x all cubed. Minus 8 divided by the natural log of x minus 2. So here you got to know a couple of things. The main thing is you need to know what is the natural log of e to the second power.
It's 2.
It is 2. So first note that natural log of e squared is equal to 2. Why is that?
Because you
Bring the 2 to the front, natural log of e is 1, right? So my numerator looks like 2 cubed minus 8. That's 0, where it comes from. My denominator looks like 2 minus 2. It's also 0. We got a 0 over 0 form. try something else. Okay, so what we're trying to do is factor something like a cubed minus b cubed. That's something you remember how to factor that? A couple years ago you did. Let's make it an easier problem than that. Let's just use an, I don't know, let's, instead of writing the natural log, let's write that as some number cubed minus 8. And if I have a number minus 2 on the bottom, and when that number is 2, I get 0, then my bet is that n minus 2 is a factor. Yes, sir.
What is that called something? Or is it
The difference of cubes.
okay?
So there is a formula. I never remember it because remember we can divide. If I think this is a factor of that, you can divide this by that to find the other factor, either with long division or with synthetic division. Let's see if you remember it. See if you can find the factor of n minus 2 in the numerator and what the other factor is going to be. You already know the factoring formula, use it, but I never remember the factor. Long division or synthetic division, your choice. After we get started, if you use synthetic division, we're assuming that n is equal to 2 is a 0, so we put a positive 2 out here. Then I need to put the coefficients of n cubed, n squared, n to the first power, and then the constant. So I have a 1n cubed, I don't have any of these terms, and I have a minus 8 here. That gets you started anyway? Let's remember that. Bring down the first term, multiply, add. Bring down the first term here, 2 times 1 is 2, add. 2 times 2 is 4, add. 2 times 4 is 8. This is what we were hoping to get, the 0 remainder. So these are the coefficients of a polynomial 1 degree less. And that tells me that this factors as n minus 2 times 1n squared plus 2n plus 4. I use n in the place of natural log of x. So now I'm going to go over there and factor that one using the natural log of x instead of n. So I'm telling myself I checked it. I have the 0 to 0 form. I'm doing more. I'm factoring. So I should get a factor of the natural log of x minus 2. Then I should have the natural log of x all squared. Plus 2 times the natural log of x plus 4, all divided by that same denominator.
Natural log function, you can put the square root of that function.
Like putting it in here, yeah, you could do that. It's a little bit awkward looking with logarithms, but I've seen it done before. And so now you cancel common factor, and that will allow you to take the limit. Each log of x becomes the natural log of e squared, which we agreed over there was 2. So we have 2 squared plus 2 times 2 plus 4. So maybe that's 12. Just waste a really good problem. Put that on the test instead of doing it here.
You should put it on the test as well.
I'm blind.
It's such a distract form.
I'll just put a plus.
Oh, please don't. That would just. Put a whole thing on. Wait, no.
I have to go to this. Either the -2 and put a plus there.
Get out. Wait a second. But then it just what that was. I know it. Then it was.
I do
So
this.
everything should be 1 over. And then.
Oh, okay.
Yeah, you might get different factorization. You might want to play with that to see.
That'd be -8 plus -8. Right?
Sorry?
Wouldn't it be -8 plus -8?
Yeah, if I made that a plus.
You have to make that.
Well, we still might get problems. How are your derivatives? How confident are you in your derivatives? Really confident?
I like the weird shapes.
Uh-huh.
When I was like doing the derivative of something, and it was asked, it was like one of the first questions, so it was we do it by the definition.
Definition?
But for like the last step, I was just not doing the whole thing. But just like, rules,
Lazy.
like, and it like gave me something that I couldn't figure out how to do.
Find it. I'll figure it out. I do want you to be able to take the derivative using the definition all the way through.
It was the x 4x plus 3. Oh no, it was 1 over 4x plus 3.
4x plus 2.
Yes.
All right, so let's find f prime using the definition.
Makes me tired of it.
You want to do it on the board then? Will that wake you up?
I'll probably mess it up.
That's a confident fella. Zoom this last time. I can't zoom it today. first step. Not the algebra that you need to do. So the first time through, you replace this x with x plus h. You have the function as you see it. Divide by h. First step okay with everybody? Okay, get to the first step, and I don't know how to help you beyond that. We gotta make sure you understand the first step. Somehow we have to combine those two fractions together so that we're able to make the cancellation with the h on the bottom. We need a common denominator. So I need this denominator here, I need that denominator there. That means I'm gonna multiply this fraction by 4x plus 2 over 4x plus 2. I'm gonna multiply this one by that 4x plus h plus 2 over 4x plus h plus 2. Common denominator. That's a big old denominator, so I'm not gonna write it twice. I'm just gonna put it in here. So this one comes up here. That one goes up there. I'm not going to multiply the bottom out. See what I did get from the first line to the second? One thing I'm going to do now is multiply this out in here. Then I'm going to distribute the minus sign, and hopefully everything cancels except for the h. Copy down to 4x plus 2. Inside here, I'm going to have 4x plus 4h plus 2. We'll have all that mess down there. Write that in the bottom as well as 4x plus 4h plus 2. That'll help me when I take the limit. All of that's over h. It's starting to string out too long. Can I go ahead and say that dividing by h is the same as multiplying by 1 over h? That mess anybody up? And now I'm going to go ahead and distribute the minus sign just with my eraser. That. And everything happened the way I want it to happen. The 4 x's are gone. 2's are gone. So all I have left on top is minus 4h. I'm about to get rid of that h. Once I cancel it from here, I can go ahead and take this limit. So this term is going to go to 0. Nothing else has an h on it. And what's left?
4x plus 2 squared.
Okay, and on top, I still have the -4.
You want us to take out the 2?
Care about that. But that might be the comment that if you take the derivative of this just using the derivative rules, maybe it doesn't match.
Yeah, that's what I think.
So let's try that. Let's take the derivative of this using the quotient rule and see what we need to do to get them to match each other. Okay, take the derivative using the quotient rule.
Yeah, I'm trying to do like 4x plus 2 to the -1. That way.
We don't have those rules yet, so I can't do that. But then you use those rules. We have bottom times the derivative of the top. What's the derivative of the top? 0. Minus the top times the derivative of the bottom. The 4 there. All over the bottom squared. We do the same thing then, don't we? That just multiplies to 0. And so we don't have to simplify. That's now. That's left out before you. Can you handle something like that? The logarithms are right. You want that fluid?
Okay, so I know it's hard to change. But why don't you just like, if you wanted to do the 4x plus 2 to the -1, you take the derivative of that and then you take the derivative of the inside, so you can multiply by 4.
So it should give you the same thing.
Yeah, that's what I messed up on. I didn't do
What
it.
about the
I
inside?
didn't do the inside.
It's kind of a bummer to keep something you already know. And you don't know part of it.
Okay, I can pretend for you.
Don't make mistakes.
Wow. I was,
No, no mistakes are allowed. I never make mistakes in here, do I? What else are we going over? Yes, sir. So nobody's worked through the review sheet. Hurried and got it posted so that you had plenty of time to work it for class on Friday. I'm sorry? You didn't see one?
no, it's on. I looked at it.
Good. I printed it, so I know I looked at it.
So it's problem 13.
On the web work that's current,
This one.
okay? See if red shows up. Red? No, red is bad. Oh, blue. All right, what does it say?
F8 equals G to the 4th.
Didn't we just do this?
I'm sorry, I'm not asleep.
We did?
So you get the
Finding where the derivative was 0?
and you get 0, you get, what is it, 0?
This went backwards
Negative
nicely.
4. Yeah.
when you, even if it's worded funny, when you see slope of the tangent line, what pops in your head? Derivative. Horizontal line.
I'm not, there's no problem with what I want. I got the,
That's the tricky part in math, is learning how to read.
I think so.
Yes, sir.
I can check right now. Spider-Man.
All right, this is from the review sheet. NB. B, okay. NB says f of x is 10 plus the square root of x. And we want to find f inverse. And we want to verify that they're inverses. By computing the composite function. But I want you to do more. I want you to graph f versus f inverse. And we put them on the same grid.
That one, I'm just gonna eye it.
So the steps were replace y, replace f of x with y, swap x and y, and then I'll solve for that y. The formula that you get will be f inverse. Yeah, we do. We do. That blue didn't show up so great either. Start the 10. And then you square both sides. So that's the formula for F inverse, but we have to add the disclaimer that we have to restrict the domain of this thing because this guy right here, as you read it, is not a one-to-one function. Parabola that opens upward. You have to figure out which part of this to keep. Okay, so let's do the graphing part. Can you tell me what the graph of this looks like? Got the square root of x, which looks like what? Accolade from the origin with the endpoint on the origin. What does that intend to it?
Rocket ship.
Rocket ship. Right? Pick it up 10 units. So it goes through the ordered pair 0, 10. And then it climbs like that. This thing here is a parabola whose vertex is at the ordered pair 10, 0. Let's put that pair right here. But I don't want the entire parabola. This function is defined for x greater than 0.
That's why.
So this one has to be defined for this y greater than 0. All the y's are greater than 0, right? This thing has as its range, what's the range here? Look at the picture.
Oh,
10 to infinity. So this x has to be strictly bigger than 10. So I can't sketch the parabola over here. I only have to sketch the parabola that way. So there's F inverse. So we have to make sure we keep only x bigger than or equal to 10. So that's part of finding F inverse. Telling me that it's only half of the parabola. Now to do the verifying, we take this thing here, stick it inside it here. See if that simplifies back to x. Now we're going to compute F of F inverse. So we write down the rule for F, 10 plus the square root of something. And the stuff that goes in there is this. So you know that taking the square root of something squared gives you the stuff inside, provided the stuff inside is positive. That guarantees that the stuff inside is positive. So that part here allows me to do this step. And so I do get x. Good. Yes. Where did the 10 come from here? This one? I'm
Oh,
finding the composite function. So that 10 was there, and then I replaced that x with F inverse. Okay, here's my next question. Order for F of x is equal to square root of x minus 8 divided by x minus 64. In order for that function to be continuous, for all real numbers, we need to redefine f at x is equal to what point, and then as the single point discontinuity here. I don't want all real numbers. I want it for all positive numbers.
do the canceling thing again.
It's a single point discontinuity. Tell me where it is. It's at 64. Anybody see why? New numerator zero at the same time. And we're gonna redefine F to be that graph when X is different than 64. And then we gotta find a number to put in that box that fills in that hole. Point discontinuity, find the value of X that fills in that hole and it goes in that box.
Cancel the top.
Okay?
Still like the X.
As long as you're not left with 0 over 0.
What we say plus.
Zero over 0 is telling us that the limit might possibly exist. So you're going to find the value of the limit as X goes to 64. Whatever that value of that limit is the number we want in that box. A function's continuous at the point. If its limit exists, value of the function exists, and it's the same number. So we're trying to make the value of the function be the same as the limit of the function. Anybody have a number yet?
Oh, yeah, before that.
Plug it in.
I think I have.
What do you got? 1/16 is correct. 1/16 is correct. We're taking the limit as X goes to 0, 64. This thing here. A couple of ways to approach it. I'm kind of curious how you did it. What are we gonna do? You multiply by the conjugate? So we will FOIL out the top. We'll leave the bottom factor because we're hoping to cancel. What do you get when you multiply out the top? You just get X minus 64, right? That times that gives you X.
Get you this back.
The middle terms cancel out. And then there's the minus 64. And that cancels for us, and we're just left with that one on top. And the X squared of X plus 8 on the bottom. So when we put the 64 there, square root of 64 was 8, and then the 8 plus 8 is going to give us 16.
This time, it's
So that's the number that goes in here.
okay.
Okay, everybody? Okay, I found another one I like. Should open this book more often. Find numbers A and B so that the limit as x goes to 0, square root of ax plus b minus 1 is in the numerator. Square root of ax plus b is one term. Can't make it dark enough for that camera. So that limit takes on a value of 1. Trying to work backwards, almost working a similar problem like this backwards, so that you can figure out how to make that limit exist. So the only way that limit has any chance of existing is if it has the form of 0 over 0. Right? Does that give you any of the A's or B's? In order to make that have the improper form of 0 over 0, one of the variables is given. Right? So which one needs to be 1? B has to be 1. Because as x goes to 0 on top, I want my numerator to go to 0, and the only way that can happen is if b is 1. So b is 1. B is equal to 1. We have 0 over 0 limit form. Okay, so now let's put a 1 where the b is. Let's see what we have to do to it. Now we have the limit of the square root of ax plus 1 minus 1 over x. That limit to equal 1 has the right form of 0 over 0. Let's do what we did a second ago. Multiply by the conjugate and see if I can get the x to cancel, and then if we have a value of a.
I'll wait you to do it separate.
This step right here. That's what the conjugate's going to look like. It won't put top and bottom by that. As before, I don't multiply out the bottom, I'm just gonna multiply out the top. This times this just gives me ax plus 1. Middle terms add each other out, and then I have a minus 1 on the back end. So the ones add out, I have an ax on top. And I have x times that square root stuff. Ax plus 1 plus 1. Now we can take the limit. Let's see what we get. Well, we can't take it yet. I got to cancel that x. Then this x is going to go to 0. And so we're left with this. Taking the limit, x is got an a on top. That's canceled. I get the square root of 1 plus 1 on the bottom. So I have a divided by 2. And our original premise is find me a value of a that makes that limit equal to 1. Got it? Need that to be 1. A must be. How to make it where?
Right? Wait, no, wait. Oh, I'm dumb. I'm so dumb.
I want the limit to be 1. The limit has to be 1, so a has to match the denominator.
I really got to
So
that
this
step.
was given, and that's where I'm using that right now, after I've taken the limit. You didn't like that?
No, I got lost in your work for a second, but I found the right answer. But then I found it.
You found that work? It matches your work? Guess them. You multiply both sides by x? Mean that equals 1?
Yeah.
And then multiply by x and solve for a? So what has that got to do with the limit? What would you do if I multiplied by x? I mean, that makes a really messy algebra problem, right? If I had a 1 over here and multiplied by x, then I got x is equal to that. That looks like a really messy algebra problem. Try? Did you do that?
No.
You try it? Stop that trying it? I think that might lead you down a messier path. Okay, so I want you to be aware what's in chapter 1, because what's in chapter 1 allows us to do stuff like this. Some of the stuff in chapter 1 that we didn't talk about was, what if you have something like, say, the sine of the arctangent of, I don't know, 2. Find the exact value of the sine of the arctangent of 2.
Rules. Find the derivative.
Find the exact value of the sine of the arctangent of 2.
Oh, we do the triangle thing.
Triangle thing. The arctangent of 2 is some angle in a right triangle, and we take the tangent of to get 2. tangent of give us 2. Right, so I'm saying the arctangent of 2 is an angle if and only if the tangent of that angle is 2. And I don't need to know that angle. If I know the value of one trig function, I know the value of all 6 of them. In particular, the value of the sine of that angle. Just by drawing a right triangle, it has the proper ratio of sides that simplifies to 2. Which 2 sides of the right triangle we talk about when we talk about tangent? So I can call the opposite length 2 and the adjacent length 1. In order to get the sine of that angle, I need to know the hypotenuse. What's the size of the hypotenuse? 1 squared plus 2 squared is hypotenuse squared. The hypotenuse is the square root of 5. Now, what's the sine of the arctangent of 2? Opposite over the adjacent. That's something you remember how to do? Okay. I want you to be aware of domains of functions and ranges so that you can restrict domains and ranges to get the inverses. Know those basic graphs? Yes, sir.
The first mistake you've ever made is spelling Mark wrong.
Hey, Mark, so
We should,
I thought it was funny.
write this down in the history books. It's the only time you'll ever make a mistake. It's English.
It's a dyslexia thing. Plus, talking and writing is nearly impossible.
Our physics teacher was famous for that. She would like write little gibberish while she was trying to talk.
Okay, so go to the review sheet. I kind of like the little blue reviews at the end of each chapter. That's where I got a lot of the problems that we did today. So if you need additional problems in the review sheet, the little chapter tests at the end of each chapter is good. Sorry? If you want to turn them in, I'm ready to take them because I live to grade. Test is Monday, in class.
Yay.
Everybody be here. Find problems on the review sheet that you get stuck on. I'll be around this weekend. Send me an email. I can help you.
16. Did I simplify this?
I got any glasses that say 16.
Did I simplify it enough?
Yeah, don't worry about it. That's,
Okay,
that's
cool.
very good.
Yeah, because I put it in the calculator and it was like.
Yeah, I don't wanna